All right, here's lesson 9.3. It has to do with integrating trig functions. So 6 of the integrals for trig functions follow the rules for derivatives. So if you think of the rules for 9.2, obviously we're doing the inverse of those rules when we integrate. So what is the integration of cosine? The answer is sine. What's the integration of sine? Negative cosine, right? And we got to be careful with those signs. Here's with the hook. Secant squared goes back to tangent. Cosecant squared goes back to negative cotangent. Secant tangent is secant, and cosecant cotangent is negative cosecant. So it's the signs and memorizing the rules, and you just got to get over it, and you got to work, and you got to know them. And so the best way to remember them is to practice them. So let's look at example number 1. It says 2 other rules can be developed by using these identities, tangent sine over cosine and cotangents cosine over sine. So can you integrate tangent? Well, tangent is sine over cosine. And then I want you to think of that as 1 over cosine times sine. And the reason I want you to think of it that way is because the integration of 1 over something is ln, the natural logarithm, and then the hook, the derivative of cosine, is sine. But we need a negative. So the derivative of cosine is negative sine, so we need to correct that. So we include the negative and then undo it. And then we integrate. So again, 1 over is ln, so it's negative ln of cosine x. And there you go. And don't forget the candy. So you know that is the rule for tangent, but now you know where it comes from. Here's cotangent. Same idea. Cotangent is cosine over sine. And we're going to write that as 1 over sine times cosine. Now in this case, the derivative of sine is cosine. It's not negative cosine, it's cosine. So the hook is there. I don't need to undo the negative or anything. How do I integrate 1 over something? It's ln. So it's ln, the absolute value of sine x. The hook is already there for cosine, and then don't forget the candy. So 1's negative, 1's positive. That's the rule for tangent and cotangent to integrate. And if you forget, you can go back and write it as sine over cosine and use the other rules, or cosine over sine. So here they are. Tangent and cotangent. There are 2 more rules for you in the box and where they came from. So now let's integrate. So number 3, how do I integrate sine? So the integration of sine is negative cosine. So that negative 3, if you like, can go in front. To integrate sine, it is negative cosine. Don't forget the candy. And the negative times the negative makes the answer positive. Here, I'll do it down here. Let's try again. Cosine pi over t. Well, this one has a hook. Now, pi is just a constant. So if the hook is pi in front, then I undo the hook with 1 over pi in front. And so the rule for cosine, so 1 over pi will be in the answer. The rule to integrate cosine is just sine. So it's sine pi t, and don't forget the candy for integrating. Number 5. The hook for y cubed is 3y squared. So I need to write this as 3y squared, secant squared, y squared dy. Undo the 3 with the 1/3 in front, and then the rule. So the hook is already there. The rule for secant squared when you integrate, it's just tangent. So we write down 1/3 tangent y squared. And don't forget the candy. Or y cubed. That should be a 3 in there. So y cubed. All right, next one. Secant tangent. What's the rule when I integrate secant tangent? Well, that's the rule for secant. Is there a hook for 2x plus 1? Yeah, the derivative of 2x plus 1 is 2. These do have to match each other for the rule to work. So we need a 1/2 to undo that 2 that we need for the hook. And then just follow the rule. So the rule for secant tangent, when you integrate it, it's just secant with a 1/2 in front. So 1/2 secant, the 2x plus 1 And then don't forget the candy. 7. Cosine over sine squared. All right, so now let's look at this. Another way to write sine squared, we're integrating this, is sine to the negative 2. And if you like, I'll put parentheses here and put the negative 2 here. Instead of in the middle, I'll put it on the outside. Maybe it's easier to see. Maybe not. The hook for sine 5x, so the derivative of sine is positive cosine, but there's a hook, and the hook is 5. So I see the cosine 5x, that's derivative, but I need the 5. That means to undo the 5, I need a 1/5 in front. And then we're going to be ready, and we're actually going to use the anti-power rule in this case. Now, the anti-power rule, we're going to have the 1/5 in front. That means we're going to add 1 to that exponent. That's sine 5x, add 1. That's negative 1, and then we divide by negative 1. So, dividing by negative 1 times negative 1. What's going to happen is that, and don't forget the candy, it's going to be negative 1/5. And then you can see that. And that's beautiful. That's it. Here, secant squared over tangent. So recognize the derivative of tangent is secant. So if you like, you can write it as 1 over tangent times secant squared. And then recognize that the derivative is there. That's the hook. Now 1 over is ln. So it's going to be ln, the absolute value of tangent theta, plus the candy, and the hook is embedded in there. All right, turn the page. Example 9. This problem is quite simple to integrate correctly, but it does require a trig substitution. So, when I look at tangent squared from the basic Pythagorean identity of sine squared plus cosine squared equals 1, you could divide everything by cosine squared. So if you divide by cosine squared, you get sine over cosine, which is cotangent. You get cosine over, or sine over cosine, which is tangent squared. Cosine over cosine, which is 1. And then 1 over cosine, which is secant squared. So you can take that basic Pythagorean one, and there's 2 others that can come from it by dividing to rearrange it. So if I look at this to rearrange it, tangent squared really is just the same as secant squared minus 1. But you can only know that by knowing that Pythagorean identity to do that substitution. Now, why does that make it easier? Because that's a rule. Secant squared is a rule, not tangent squared. And so when you integrate secant squared, well, that's the rule for tangent. And when you integrate subtract 1, well, that's just a basic anti-power rule. That's x. And then the candy. Example 10. Find the area bounded by y equals 2 cosine x, y equals 1/2 tangent x, and x equals 0. Set up the integral and then use your calculator. So let's graph this. 2 cosine x starts at 2. And then at pi over 2, well, the value of cosine at pi over 2 is 0. So there's a curve right here. And it would continue on, but I don't need it. Tangent, if I plugged in 0, the value of tangent at 0 is 0. So it's 0 times 1/2. And 1/2, well, this is going to be curving up. Now, it'll be curving up, in a fat-like way, but it's still curving up. And so you can see with x equals 0 that this is the area shaded. To find the area trapped between 2 functions, it's top subtract bottom, but I need to know where that intersection is. So we need to set this up. So a good place to start, is to see where they intersect at that point right there. So if I use a calculator, which I will, let's try it a couple different ways. Oh, let's go on. You can see it. without the shine in there. So first of all, I actually have to solve this. When does 2 cosine x equal 1/2 tangent x? Let's see if my calculator gives me a nice answer, or if I have to graph it. So I'm going to press a menu. I'm going to go to, I don't know why this is just such awful to see that shine on there. I see it. Let's see if I get the shine off there. Okay, that's a little bit better. All right, I'm going to go to algebra, and I'm going to solve. I'm just going to type it in. And if it doesn't work, I'm going to try a different way. So cosine x equals 1/2 tangent x move my cursor, tell it to solve for x, so comma x, and let's see if it gives me an answer. Awesome. So something went wrong. 2 cosine x equals 1/2 tangent x. I'm trying to think, what did I type wrong? Because clearly it's not negative 961 where they intersect when x equals that. So what did I do wrong? 2 cosine x. When are they equal to each other? Well, it doesn't like me that way, so I'm going to do it a different way. So I'm going to go and I'm going to graph it. So first, I'm going to graph 2 cosine x. Then I'm going to press another tab, and I'm going to type in 0.5 times, maybe I didn't do that, 0.5 times tangent x. Cool. And then we're going to find that point of intersection in the first quadrant. So to do that, I'm going to go to Menu, I'm going to go to Analyze, and I'm going to go to Intersection, which is 4. So I want to set this up. So I'm going to press Enter. I'm going to set it up and go over the point of intersection, press Enter again. And then it gives me an answer, though it's kind of like over all that, so I'm going to like click it and just move it a little bit so I can actually see it. So I get 1.082. I'm going to use that. Not quite sure how I'd save the entire thing. There probably is a way, but I'm going to use 1.082. So go back here. I'm integrating from 0, and we just said the x value is all I needed. That's 1.082, and I used my, I don't care about the y coordinate, the x. So 0 to 1.082. In its top, subtract bottom. So which one's on top? That's 2 cosine x. Subtract what's on the bottom. That's 1/2 tangent x. And then again, I'm going to use my calculator to integrate that. Now, let's go again. So I'm going to go Menu. I'm going to go Analyze. And I'm going to go to Integration, which is 7. And it'll say from where to where. Well, let's see. So it says graph. Yes, that graph. Enter. And then what's the second graph? Tick, 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 tick. So the lower bound is 0. And then the upper bound is 1.082. Oh, it didn't do what I wanted to do. It found just, it didn't go between the two curves. It shaded everything all the way down the x-axis. Let's try it again. Analyze it. if I'm doing the, a bounded area, I should have done the bounded area. Let's try the bounded area. The lower bound, again, is 0. The upper bound, again, is 1.082. And then there's my answer. I'm going to click it and see it. So it's, can you see it? It's 1.387. All right. So you could probably teach me more than what I know about the calculator to make that easier. But you have to use your calculator to find the point of intersection, and then use your calculator after you set it up to find the approximate area trapped between the two curves. All right, so now you can do assignment 9.3, and we'll go from there.